So let's do the meta now. Remember the meta, I already put these there. The meta would be attached right here. Because that's the meta position. Of course, it could be on the other side, but it's easier to start here. So here's our positive, the carbocation. So you know that the resonance would be moving it toward that bond, moving the pi electrons, and then you would have the NO2, the H, positive is right there. And then, of course, one more would be moving these electrons over. Positive is down here. Here's NO2 and the H. And there's one thing you need to realize is that none of these resonance structures allows a structure to have an octet. So there's no octet on one atom. So on one atom. So in this case, the carbon atom, in this case, this proves to be not as stable as having all of these. If you notice here, they all have octets. In this case, especially at the last structure, there isn't a single structure here where you have an octet on every atom. So one of them, especially this one, has no octet. So that's why meta is bad. So now finally, let's do the para. And we actually need to just readjust the para here the way it was drawn, because we need it to be added from the bottom. So it would be like that, because the para is that position right there. Let me erase this. Very well. So you would have this untouched, that untouched. You have your positive charge right there. And then you have your NO2 and the H. So draw the other resonance structure for this. There we go. Where is our positive? It's right there. So the next structure would be moving this around. NO2 and the H. And then let's put the lone pairs on that O. We need it. We need to show them because we need them actually. So these would come down and then these would move. And if you look at this, every single atom has the octet in that last structure. So very stable. All atoms have the octet. Every single atom has the octet. So that explains why electron donating groups, activating groups prefer the ortho and the para. And the meta is just a bad option.